Dominic introduce himself, and I won't start the timer until after you've introduced yourself, to be fair to everyone. Okay, thank you.
Yeah. Okay, no problem. So my name is Dominic Giel, and I'm from Offenburg University. I'm a professor for physics, and I'm teaching engineering students in the early studies of their bachelor degree. And also I'm giving the preparatory courses, which should prepare the students, the freshmen, first-year students, to their studies in engineering, mechanical engineering, and the like. You can start the time right now, because I think I have one slide. I reserved one slide for myself. So okay. Yes, thank you, Thomas, for the introduction, and thank you for the possibility to produce our research. This international conference, I'm very excited, because usually I don't get to speak to people from Japan or from Malta. It's a very straightforward talk, I think. I'm going to give an introduction. What are we talking about? What is the preparatory physics courses in Offenburg University? And then tell you some things we had to change due to the pandemic situation in the last year. And I'd like to give you an idea what is the problem with the changes we've made. And last, I'm going to show you the results. I'm not going to interpret it too deeply, just show you what happened to attendance and dropout in our online version of the preparatory physics courses. Okay, first slide, I've introduced myself. So where's Offenburg? You might ask yourself. Offenburg is in Europe, in this red box here, and if you zoom in, you see that it's next to Strasbourg. People from France might know that it's next to the border to Strasbourg, and Strasbourg is between Frankfurt over here and Zurich down here. So it's a rather small town, and we have a small University of Applied Sciences funded as a School of Engineering, and we have degrees, bachelor and master degrees in business, in media, and also in engineering, which is the main course for our preparatory courses. Despite the fact that it's close to Strasbourg, it's rather rural area. You can see when you look outside our campus, the black forest should be painted black here on the side, and we have two campuses. One is rather old-fashioned; it's an old monastery in a Reichsabtei, Gengenbach, and one is rather modern, where we hold our courses. So the students, before they start learning on engineering, we make a repetition on the school curriculum. And we've heard one talk on the decline of interest in science, and that's actually true. We make one pre-test each and every year, and we see that the interest and also the skills in science decline over the years, unfortunately. So every year the freshman has a little less knowledge on science and on physics, and we hope to fill in the gaps with our preparatory courses before the first year starts. We do this not only because we like science, that's also one thing, but we have in Germany the situation that we have 27% of students in bachelor degree programs in the higher education institutes, they do not graduate. The 27, the number is not fixed. It depends on what do you define as not graduating. Some people stop their studies and they change degree and then they graduate several years later. Did they stop studying? Or some people stop studying, work for several years and then restart studying. Did they cancel their degree? So the 27%, this is not a number which is fixed, but it's generally considered to be a dropout. And even if this dropout is late, meaning that it's in the second year or later, it's considered to be costly for the universities and also for the students. And government wants to reduce dropout in higher education. And there are several investigations. What is the reason for dropouts? Usually you need more than one reason, except if it's a mental problem. it's a not mental, it's a health problem, then you need just one reason. But if it's more than a health problem or different from a health problem, then you need usually more than one motive. But to sum up, it's dropout occurs when the student performance and the requirements of the program chosen is not a good fit. To sum up, so we think the preparatory courses are a good way of projecting the requirements of the student and also of increasing the skills of the students and homogenizing the students' skills of the whole semester. This is why we are interested in preparatory courses, to lower dropout in the studies. And actually, we also monitor the dropout during the courses to see if our courses are accepted and are helpful, because we think since it's a volunteer course, people will follow the whole course if the course is of any interest to them. Okay, this is what we get in conventional years. So this is, maybe you might want to increase it. It's not so good readable, but the blue, well, this is 100% where the red dot is. This is 100%, and this is winter term 2015-16 preparatory courses. 100% of students started, and approximately 60% finished the course. So there's a gap between 100 and 60, meaning we lost 40%. This is the next term, winter term 2006, 2017, and so on. And I have made the 4-year average. So 43% do not finish the preparatory course. Actually, the preparatory course, maybe they already have all the skills. And those who do finish, they make a second test, not only the pre-test, but they make a post-test, and they score higher in the post-test. One is tempted to say, well, they learned something during the course, but actually, no, the students with higher pre-test, they are more likely to remain in the course. So it's not very surprising that the students which finish the course actually achieve higher marks without changing their skill. But still, this number, I plotted it in orange here, is around 150%. So 50% gain for those who finish. That's not good or bad as a number for itself, but I introduced this to compare this 43% finish, and they improved to 150% to the results of the online course, because when Corona started, we suddenly had to change our concept to online-only courses. This is a problem because, well, the courses are usually half-day mathematics, half-day physics. They last 2 times 360 minutes in classes, and we use a combination of lecture and blended learning assessment. We have one physics app, one mathematics app, and the apps include exercises, textbooks exercises with a guided solution. So in the conventional courses, people hear a lecture and then they have to solve exercises, and they can share their findings with their classmates, and they can check on the blended learning app if their solutions is right. And this is okay. We have like a dropout of around 40%. And when we had to change to online, we had some expectations what happens to the dropout, because very few people can attain 360 minutes just regarding videos and doing exercises. So we had to rethink our concept, and this is what we introduced. We reduced lectures, so to 90 minutes, which is to me something which is the upper limit for one lecture. And we put all the students, which usually are in the different courses, in one Zoom room. And we use the requirement catalog for all engineering degrees, which is something which all colleagues agreed to. So we increased the scope, focused on general physics, the curriculum of the school. And we introduced peer instruction. Then we added 90-minute exercises, but we gave detailed instruction for the group exercises, a combination of a guided textbook exercises and a daily group exercise, which consisted of one physics problem, but we didn't include all the numbers you needed to a straightforward solution. So they had to do internet research, or they had to do a group discussion to finish the group exercises. And we did pre and post test as usual. We picked the same question, and but instead of writing it on paper, we've used the version as a Moodle test, Moodle quiz with the same questions. So this is a bit change of game, because we don't know if they used additional sources to come to their solutions. Yes, 5 minutes. I want to spend a few of the 5 minutes to the peer instruction concept, which is very interesting for online, because you can easily subdivide your audience into subgroups. And it runs this way. You pose one question, and you have the students vote, online voting. Then you show them the results of their votes, and you don't tell them what is the right answer, but you let them discuss themselves in small groups of 6 people. And then you redo the voting. And then the lecturer has one idea of what is the level of discussion. And if all are completely wrong, he can intervene and can tell you, well, that's what you think, but in general, it is agreed that the density of water is 1.02, even if you type in 50 or whatever. And in this way, you can, as a lecturer, easily see if you're doing the lecture in the right speed, or if you can advance faster or more slowly. I have one live demonstration of the thing. I've prepared one question, one question. I will post this in the chat. This is open. You can see for demonstration. If you click on this, please let my tab open. Don't close my tab. Open another tab on your browser if you use it. And you can answer one question. What do you expect to happen with the dropout due to the online only nature of the courses compared to the conventional courses? This is 40%. The dropout is dramatically reduced in online courses, slightly lower in online courses, not significantly changed in online courses, slightly higher in online courses, or dramatically increased in online courses. Okay, I will not switch screen. Usually I'd wait a few seconds for the answers to come in. Oh, 3 people actually did vote. Well, usually I'd share the screen with you. So the majority, 2/3, says an answer slightly higher in online courses. Yes, actually, that was what we hoped would happen. Answer D is what we hoped would happen. But, ta-da, actually, we found out that the dropout ratio is slightly lower than in conventional preparatory courses. So I checked the statistics. It's a bit difficult to say, because people show up on the post-test, but they do not finish the post-test. So what do I say to them? Did they finish the course? They actually started the post-test, but they got bored from the post-test and they abandoned board test. So if you count them in, you get a slightly higher, you get a slightly lower. I said, well, that's my error bar. So 34 plus minus 3% is the dropout ratio in online courses, as compared to 43 plus minus 5% as in conventional preparatory courses. So the right answer, let me go back, is actually B. It's slightly lower in preparatory courses, calculated from the 4-year average. Okay, you can also monitor the attendance in online by looking at the by the attendance. This is what Zoom gives you, and you see. I'm a physicist. I'm sorry. I call this an exponential decay. Don't worry. The students are not actually dead. They just were on another place. They don't show up online. So I get the decay rate with a half-life time of 18 course days. So after 18 course days, you have half the attendance. Okay, this is correspondence good to the dropout rate we calculate, because this is very close to the 40% dropout rate. Okay, last slide, 47 seconds. The attendance and dropout is similar to online courses. If the lecture monologues are shortened, if you use peer instruction, group interaction, and blending learned elements, and the post-test to pre-test ratio, so the results, the final results which you get, you remember this bar here, is even higher. I didn't plot it because it would be too high for this slide. It's 350%, 3.5 times, which is not good or bad as is, but compared to conventional courses where we have the same dropout and we only come to 150%. Taken with a piece of salt, because we have this electronic format, and maybe the electronic format is a bit changing this. So, okay, this is 50 minutes on my watch.
Okay, well, thank you very much, Dominic. That was a very interesting talk. I was particularly interested, just speaking for myself, please begin typing questions, everyone. But I was particularly interested myself in the technique you described of polling a group for, answers to a multiple choice question, and then discussing it without telling them the right answer, and then deciding whether they needed additional material or not based on that. I think that actually could have applications in a wide variety of contexts. But yeah, so does anybody have any questions they want to ask Dominic? Deafening silence. I'm aware it may take time, obviously, for people to type things in. So if you can just type, I have a question or something if you want, and then I will wait. Okay, so while we're waiting for that, so just to make sure I understand, these courses, are these intended to bring students who lack familiarity with physics and maths up to a certain bar as they begin their university studies? Have I understood that correctly?
That's correct. We have students which come directly from school, and we have students which have worked for several years, and it's a not very homogeneous first year. And we know from the first year physics, first year mathematics, that some of them take a few months to adapt to the academic routine, and some are already in it. And we take 2 weeks to show them what working with their classmates will be, and what is the level of exercises. I mean, they all heard about, for instance, linear algebra. They all know theoretically that there is a quadratic equation, but they're not really used of solving it within 5 minutes. So we give them their exercises. They know, and theoretically they know what calculation with fractions felt like, but they're not actually in it. So the 2 weeks are good invested for them to pick up pace, because when the semester starts, they don't have time to remember what.
Yeah. It is definitely an interesting approach, because we have something similar at many universities in the UK, but that's typically spaced out rather than an intense prep. As you say, this is a preparatory course, but we have many of the same problems you've described, where it can feel very algorithmic and not engaging to the students and so on. So, and you get, as you say, a very inhomogeneous group of students. So, if you're challenging one group, you're leaving the others behind and so on. So Geetika's also got a question.
That one. Do they equip same skills as they run in different courses? Any job opportunities for them in future? So we have I think 3 times. We have the engineers. They need to have the they are offered the preparatory course in physics and mathematics. We have the business people, and they only get mathematics. They don't need physics. And we got some courses in informatics, and they get the chance of rehearse programming skills. The programming skills are part for computer science people, of course, and they will learn programming languages. But it's helpful if you have a basic concept of what a programming language looks like. If you have already solved some assignments in programming sciences, so we have a short 2 weeks course in I think Java or something like this. And this replaces physics for the computer science people. So yes, the answer is yes. There is a different. We differentiate between the grades, between the studying programs, but not very closely. So the physics for the electrical engineers, for instance, is the same physics as for mechanical engineering, because we think it's a basic concept which is applied to more problems. I tell them, don't be afraid that I'm going to teach you something which will not be within your course. So it's not a huge number of furnitures you're going to load into a van, but physics is the tool which shows you how to disassemble the furniture, so you can put them in your brain as pieces which will fit more smoothly. So the more mathematics you have, the more physics knowledge you have, the less problems you will have of putting lots of furniture into a very small van.
I think that's an excellent way of putting it.
It's not extra furniture.
Yeah, that's an excellent way of putting it. All right, I think we've just about run out of our time for questions. So thank you, everybody who asked a question. Thank you, Dominic, for that talk once again. And we now